Hello. Are we getting ready to code? I hope we're getting ready to code. Number 186, reverse words in a string to premium, difficulty medium. Given a character array S, reverse the order of the words. A word is defined as a sequence of non-space characters. The words in S will be separated by a single space. Your code must solve the problem in place, i.e. without allocating extra space. Character array S. Okay, so in Python that's kind of a weird thing to do, but so clearly we want 2 pointers, one to remember the word that we're moving, and one to remember the place that it's going to. The sky is blue should become blue is sky the. So I guess we could have a pointer on the left, pointer on the right. They both move inwards until they get to a space. I mean, that's then one of them might be longer than the other, so you might end up either not moving the longer one all the way or overwriting some of the next word. Excuse me. So I'm wondering if there might be a better way to do this. So let's say we started by fully reversing the string. So you had this, and then we turned it into E U L B space S I space Y K S space E H T. Is this an easier starting point? So you fully reverse the string, and now you just need to reverse each word. So now you could have 2 pointers. Move the first one ahead to the end of the first word. Have them iteratively go to the other side of the word while swapping each time. And then move ahead to the next word. Okay, I think that's the way to do it. So comment these just to have as reference. So we start by reversing S, which we have to do in place. So I'm going to do it with pointers also. For I, in range len of S. For J, in reverse range len of S. S of I equals S of J, and vice versa. S of J equals S of I. Let's just confirm that we are, oops, put a comma there, that we are reversing the string. No, I'm not even reversing the string. What am I doing? I shouldn't nest these loops. I need them both to iterate at the same time. So while I is less than len of s, I equals, or ij equals 0 len of s minus 1. You do this in a while loop, and then you increment both. I plus equals 1, j minus equals 1. I didn't end up changing anything. Why didn't I change anything? I guess let's try doing it without the fancy tuple. So S of j temp equals S of j. S of j equals S of I. S of I equals temp. What am I missing here? I'm starting j at the end of the string, and then I'm swapping them. But nothing is happening. Oh, actually, I want to do while you're less than j, because I'm swapping it and then swapping it back. Okay. Alright, so we've done the first step. Now for each word we want to reverse each word. So for I in, or maybe while I is less than len of s minus 1, or just less than len of s. We have two modes. We have find the next word, and we have swap inside, or we have reverse this word. So I guess we're gonna start in find the next word mode. Mode equals find. If mode equals find, then we also need a j. So I, j equals 0, 0. They start at the same place this time. If S of I is not a space, then we have found the next word. Yeah, something like that. And then we also want okay, if mode is find and s of I equals space, then you just increment I. If mode is find and s of j, you increment both actually. If mode is find and s of j, or it's not that you increment both, it's that you set j to I. So we can just scan once until we get to the next word. If mode is find and s of j, elif. Then we want s of j to get to the space. So j plus equals 1. Let's set, otherwise we're not in mode find anymore. Mode equals reverse. And then let's just check print I and j, whether this works. Oh, wait. We also need to break here, otherwise we would never finish. This is temporary. Yes, it's while you are not a space and you can still move forward. And j is less than len of s. And I should put this first. Well, I'm not supposed to get to this point. How did I get to a point where I'm at a j that's out of bounds? Show me where we are in the list. So I is 0, it starts as. I guess I just need a -1 here. Okay, so we get to 0 for I and 4 for j. Good. So once we've gotten to the space for the right index, we want to say j minus equals 1, and now we're in reverse mode. Oh, this also needs to be elif mode equals find. So now we're not in find mode anymore. If mode equals reverse, and this I guess needs to be an elif, then you do a swap and you move inwards. And you stop when they meet. So and I is less than j. Elif mode equals reverse. Now you're going to be in find mode. I've got an infinite loop, so what's happening? I'm moving between 3, 3 and 3, 4. I guess because at this point, I want my I was assuming that I was starting it after the end of the word. Which I probably should. Word end equals 0. Whenever you're done finding, word end equals j. And then whenever you're done reversing, I and j should be equal to word end, word end. I'm still getting stuck between 3 and 4. Oh, I guess actually I want word end to be at the space between words. Okay, now I'm getting stuck at the end of the string. I wonder what mode I'm in. Probably find mode. Oh, I'm alternating between them. Yeah, I guess I should say here, if word end equals len of s minus 1, then you can just break, you're done. Okay, I'm close, but I didn't end up reversing the last word. Why not though? Because I only should have gotten here after reversing the last word. Shouldn't I? Twelve, 13, 13, 12. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I mean, 14's not even... I guess this should be greater? No, now I'm stuck. I've made this complicated, I think. I think the way I'm finding is more complicated than it has to be. They told us that the words will be separated by a single space, so I don't need to find so hard. I can kind of already know where I am. So why don't we just always assume that I is at the start of a word, so we don't need to do this. J needs to find the end of the word. And then here you should go to word end plus 1. Or I can just call it next word. Yeah, next word comes after. So right now, J is the space. Plus 1 would be the first letter after the space. I'm still not reversing the last word, but I am getting to after the end, which means I don't actually need this because my while will already take care of this. But I wonder if the while ending early is what's causing the last reverse not to take place. I guess I don't understand, because we have reverse 12, 13, reverse 13. Oh. I don't think I'm at the correct end of the word. I think I'm reversing these two, and then I'm reversing them again. So I think J needs to go farther out. So here's what I want to say. If you're in mode find and J is not equal to space, or J is No. If J is not equal to space, you move forward. You reverse if it is equal to space, or wait, and J is less than len of S. But this, you only do this check if it's not less than len of S. So let's do this first. Okay, we finally got it. Let's submit. Not that fast, right? Or maybe it's variance. Partially variance. My modes, I think, are probably not ideal. Oh, I do have to go through the list twice also. That might be fine though. I could get rid of modes by just having nested loops. So like every iteration of the outer loop would be one word reversal, and then every iteration of the inner loop would be one letter in the word reversal. So the loop always starts by getting J to the end and then swapping everything. And then we go again. Which might be easier to read. I don't think it would be any faster. I'm curious to write it, because then I don't have the mode stuff. Oh, I also left a print statement in there. That might have affected the time. All right, let's quickly see if we can get rid of mode. So, while I is less than s, we don't have a find mode. We just increment j first. We don't have a mode. And then outside the loop, we do this. We actually don't need to remember j outside the loop. We can set it at the front here. J equals I. This needs to be a while. Then this is another while. And then this is just a thing you do after the while, which is move us on to the next word. Okay, let's submit that. A little bit better. It's the same thing. It's probably a little easier to read. So this is find the next word. And this is reverse the word. This is reverse the whole string. All right, next problem. Number 187, repeated DNA sequences, difficulty medium. The DNA sequence is composed of a series of nucleotides, abbreviated as A, C, G, and T. For example, ACGAATTCCG is a DNA sequence. When studying DNA, it is useful to identify repeated sequences within the DNA. Given a string S that represents a DNA sequence, return all the 10-letter-long sequences, substrings, that occur more than once in a DNA molecule. You may return the answer in any order. So the most obvious thing to do is to maintain a set. Have a sliding window and put everything in that set, and yeah. And I don't really think you can do better than that. If you're actually going to return them all, it's not like you can do something clever to not have to remember all of them. So I think that is all we're doing. Ret is going to be equal to a set. For I in range len of s minus 10, ret.add s starting from I going to I plus 10. It's not at least 10, it's exactly 10. And then convert it to a list and return it. Oh wait, it's that are more than once, right? Occur more than once, okay. So then we'll just do from collections import default dict. Instead of being a set, you're going to be a default dict of int. And we're going to index at this and plus equals the count by 1. Then at the end, we're going to say return key for key in ret if ret of key is greater or equal to 2. Submit that. Okay, I guess I didn't understand the question because now that one's not a repeated sequence. Given a string that represents a DNA sequence, return all the 10 letter long sequences that occur more than once. So how, 1, 2, is it because this is, that's 11 letters long. So why would I not return that? Let's use this test case, run it. Why would I not be finding that? Oh, I might just be off by 1 here. Okay, let's submit that. Okay. Is this variance? Possibly not. Maybe it is variance. I'm beating 86% on memory, which is funny because I'm storing a huge amount of stuff. But yeah, I don't know if you can do better than this. I'm curious. No, same as what I'm doing. They're storing 2 sets instead of a hash map for some reason, but that's the same thing. Okay, next problem. Number 188. Best time to buy and sell stock 4. Difficulty hard. You are given an integer array prices, where prices of I is the price of a given stock on the ith day, and an integer k. Find the maximum profit you can achieve. You may complete at most k transactions, i.e. you may buy at most k times and sell at most k times. Note, you may not engage in multiple transactions simultaneously, i.e. you must sell the stock before you buy again. Okay. So it's been long enough that I don't remember how we did best time to buy and sell stock 1 through 3. So we're gonna have to figure this out from scratch. Okay. Yeah, I mean, the first idea that comes to mind is to do something recursive where at each time I either perform a transaction or I don't. If I do perform a transaction, well, either way I recurse. And then the base case is I get to the end of the list. It's at most k times. So I just need to keep track of my count. That's going to be a very slow thing. It'll be exponential. But I don't know. I think we can try that at first and see how it goes. So I'm gonna add a fake extra variable here called holding pool equals false. Because I want to call that in my internal thing. So here I either buy or I don't. So if holding, if not holding, why don't we say if holding, then I either sell or I don't. Self dot max profit. I return whatever is biggest between if I bought and if I sold or if I didn't. Sell equals this. Max profit of K prices after I and false. I'm not holding anymore. Hold equals this. True, still holding. And then I return I want the max, right? Each of those is the max profit I could achieve. Give me the max of both, sell and hold. If or else, then the two things I can do are buy or do nothing. If I buy, I have one less K and I am holding. If I hold, nothing happens. Or I guess it's wait, buy and wait, and I'm not holding. Okay, then base cases, if not prices, return 0. How do I know how much profit I've made so far? So if I'm buying, then I'm losing profit. I'm losing prices of 0. And if I sell, I'm gaining prices of 0. to make it nicer, I put it over here. Then once you get to the end of the list, or if you can't do any more transactions, or k is less than or equal to 0. What chance does this have? Right answer here, wrong answer here. How do I trace out what I did? That's the hard part with the way I wrote it. I am not sure. Print K and prices and holding. We're not branching as much as, oh, never mind, there's just more. I'm also noticing we can easily do some dynamic programming on this. Because prices were always iterating forwards, so we could cache based on the index into prices that we are, instead of passing a new list each time. So I will change that, but let's just get the right answer first. This is so hard to trace. I would need to like pass in my answer so far in order to be able to print it. All right, let's do that. Debug equals none. Print the debug. Every time I recurse, debug equals what I've done so far. How do I do this? So for cell it would be debug plus cell. For hold it would be debug plus, and then up here I would say debug equals debug or empty list. Hold. Debug equals debug plus buy. Debug equals debug plus wait. Print that. And why don't you show me all of the ways that we got to the end of the list? Oh, okay. When K is, it's that you have to be out of buys and sells. So I have to say and not holding. Now I can't do anything more. If I'm holding, I can still sell. Ah, okay. Now we gotta get rid of all our debugs. Now we can add our dynamic programming. So in order to do that, we have to not pass prices like this. We have to use an index, which means we're going to define our own function signature. Def rec takes K, it takes I, which is an index into prices, and it takes holding, which is a bool. And this is what you do in there. Except that every time I talk about prices, I want to be starting at I. And then at the end here, we return rec of K, 0, false, and we can slap a cache on here from functools import cache. So whenever I'm talking about prices, I'm talking about starting at I. So this is prices of I, this is prices of I. This is just I plus 1. All of these, you don't need to slice, you just need to pass in I plus 1. How do we do here? This is not self.maxProfit anymore, now it's just rec. Let's submit. Ta-da! Look, beats 5%. Okay, so, like, I don't think you can do much better than this, honestly. It's dynamic programming, and you've got an array, a 3D array, that's K times N times 2 big. So you're computing K times N times 2 values. We could unroll the recursion into a dynamic programming and then just set stuff in the correct order, which would make it a little bit faster and would save a lot of space. It wouldn't save that much space, actually. But that's not how you get to 40 milliseconds of runtime. I guess there are heuristics you can take too, like you'd never want to sell for less than you bought. So I don't have to recurse all the way down to bedrock. Yeah, I guess we didn't use any of the tricks from the last times we did this kind of thing, which is like, you always want to buy you always want to buy at a local minimum, you always want to sell at a local maximum. That's still the case. There would be no reason to buy and sell on the way up. So I guess we could like pre-process the list so that it only has local maximums and minimums. That's an interesting idea. I do want to try that actually. So Extrema, I don't know if that's the right term for it, is an empty list for I price in enumerate prices. If price is greater than prices of I minus 1. How do I say this? I guess what I want to say is if you're in order, basically, if you're less than the one before you and more than the one after you, then you're not an extrema. Actually, I wonder if I could benefit from holding the minimums and the maximums in separate lists so that I'm always skipping ahead to the next. Yeah. No, because they should be alternating anyway. You can't have two local maximums in a row. Okay. So if you are like this, then you're not an extremum. So if not this, extrema dot append I. I'm gonna change this to be for I in range of len prices, starting at 1 and ending before the last one, so that I know that I can always do this. And I want the first and last to always be in here. So prices of I, prices of 0, and then at the end, extrema.append. Oh, it's not prices, it's the index. Len of s minus 1. Okay, so now I have all the indexes of the extrema. Print extrema. I instinctively said len of s because that's something you type a lot in Leetcode. Everything's in extrema here. I guess everything's at extrema here. Okay, maybe this is not going to make a difference. I guess we'll see. It depends on the input, I guess, because you could just have extrema everywhere, so it's not necessarily better. But then I want I to be an index into the extrema. Actually, there was no reason for me to do this slicing here before. So if I not in extrema, no, I should be an index into extrema. So if I is less than len of extrema, is greater or equal to len of extrema. Then I never want to talk about prices of I. I want to talk about prices of extrema of I. And I want to spell it right. Okay. That helped, actually. Wow, I'm on this little peak. I wonder if this is the peak of people who did something similar. Beats 24%. I would still need it to be 10 times faster to get to the next peak. Or I guess 5 times faster. Because what did I really do? I made the dynamic so it's a dynamic programming that's O of K times I. Dynamic programming. The table is K times, or I mean, not I, but length of prices times 2, because I've got holding. So I could divide by 2 by not, if I knew that whether the extremas were no, because I probably am already doing that. I don't know. I don't see how you're getting K out of it. So I kind of think I'm already around the best you can do asymptotically. I made n smaller, not asymptotically, but I'm getting rid of all the ones that are definitely not places where you want to do a transaction. I think I'm happy with beats 25%, 24.9%. think about it for another minute just to see if the brilliant insight hits us. No, yeah, I don't know. I think this is, I think this is good. I'm happy with this. Let's see how others did it. Hey, I beat 25%. What are you talking about? Oh boy. What is all this? No explanation. This is dynamic programming. I don't totally understand it. I mean, it looks pretty similar to what we're doing. They just unrolled the recursion into filling out the dynamic programming table directly. Is it faster though? Like, I guess I'm curious about how to do it faster than us. I don't know what TC and SC means. It looks similar to ours, but is this they have one-dimensional tables, and we needed a two-dimensional table of I and K. So I guess there is a way to do it faster that's like pretty simple to understand. I just don't understand it yet. I think this is similar to what we did for one of the previous stock picking questions, but I've just forgotten it. Yeah, it's a prerequisite to understand the other one. Anyone gonna explain it to me without prerequisites? This is k times n, which is what I did. Really hoping that I just click into one of these and instantly am enlightened. Because I'm trying to like skim read code that is complicated and I'm not having a lot of luck. This is what we did. This is a 2D array. This is the one I don't understand, where you don't have a 2D array, you have one array of buy and one array of sell. But I guess it's still n times k. Okay, I don't know. Yeah, I actually... Yeah, this is just what I did. Alright, unfortunately I didn't understand the ones that seem to be better than mine. Mine is not that bad either. Beats 25%, but I would have preferred to understand the much better ones. Here, you're a super fast one. But you're still n times k. You are storing only 1D caches, which is better than me. So that must be where the speed up is. I guess you're still n times k though, but you have less stuff to store. So can we understand this one? What do buy and sell represent? They're arrays of length k, so they must be the most that you could have made with the kth transaction, or like the with this number of transaction. So this is the cheapest you could have bought your first thing, your second thing, your third thing. This is the cheapest you could, the most expensive you could have sold your first thing, your second thing, your third thing. And then the answer is or I guess this is your profit after first, second, third buy. This is your profit after first, second, third sell. At the end you return your profit after the last sell. And you initialize these with you've made no profit and you've lost infinite money at the it costs infinite money, so that you always end up setting them. And then for price, And for each transaction, your buy and sell on this transaction is the max of what it already was and what it would be if you sold the best thing you could have sold so far and then bought here. Okay, I think this actually is equivalent to this. I mean, we know it is because it's n times k. It's a more clever way to store the dynamic programming table. I don't know why it ends up being 5 times faster than what I did. I get why it would be a little bit faster because it's a little simpler. Okay, I mean, I think this makes sense to me now, so I'm ready to move on. Number 189, rotate array, difficulty medium. Given an integer array nums, rotate the array to the right by k steps, where k is non-negative. Follow-up. Try to come up with as many solutions as you can. There are at least 3 different ways to solve the problem. And then here's the actual follow-up that I'm interested in. Could you do it in place with O1 extra space? Well, I guess it wants me to do it in place either way, but do not return it, or I mean, with O1 extra space. So obviously without O1 extra space, actually even, I can't even think of an easier way to do it than the way that has O1 extra space, which is to have 2 pointers. One at the offset, one at the start, and then just increment them circularly and swap. No, I guess you don't want to swap. You want everything moved forwards. So you could do like a bubble sort kind of thing where you iterate over the list k times, each time pushing stuff to the right by 1 and remembering only one thing at a time. But then you end up moving the same thing k times, and if k is big, that ends up being n squared. I'm trying to think if you can just do like nums of 0 or nums of offset equals nums of 0, and then increment both all the way through. The problem with this is, where am I putting nums of 0 in the meantime? Swapping them doesn't make sense. I'd have to have O of k extra space. If I had O of k extra space, then I could do this. And how could I do this with O of k extra space? Great question. Glad I asked it. So I'm trying to push this to the right by 3. So I can just take this and put it here. And then remember what used to be here. And then take this and put it here and remember what used to be there. Take this and put it here and remember what used to be there. And now I don't want to take this and put it here. I want to take what I remember used to be here because I've already changed to this. So another way to do that is I start by filling up a buffer of size k. And then once I get to the kth element, I grab from the first position in my buffer. So it's a queue. I take from the first position in the queue and I add this to the last position of the queue. So that's going to be a O of k way of doing it. And let me just write it down. From collections import deek. Q equals deek. And I want to start by grabbing the first k numbers. And then for I in range k to or I guess for I in range len of k, or sorry, len of nums. Nums of I plus k equals q dot pop left, and this value needs to go into the queue. So q dot append this. Yeah, that's basically it. Oh, and this needs to be mod len of nums because we're trying to do a circular. Okay, so that works. But it's not O1 extra space. So let's keep working on this. This is O of k extra space. So I can do it in O1 extra space by doing it in O of, so this is O(n) time. Obviously I can do it in n times k time with O1 extra space. That's the bubble sort idea. Like I'm not actually sorting, I'm just bubble shifting. So I go through the whole list k times, moving everything to the right by 1. So now the idea I want is like bubble shifting by offset amount or by k amount. So I want to start by saying nums of k is equal to nums of 0, and then increment both. But what's going to happen when I do that? So let's do k equals 3. Excuse me. So I'm going to say you're 1, you're 2, you're 3, you're 1. Like I'm going to lose the information. So if I swap them instead, then what happens? So you get to 4. You become 2, you become 5. You become 3, you become 6. Then I want you to be 4, but you're not going to be 4. You're going to be 1, and you're going to be 7. So you can't go through the whole list like that. But I can go through how much can I go through? I can go through the first k like that, and that's going to give me the right answer for these k. Like I'm going to have moved the first k from where they were to where they should be. Then the next thing I did is bad. So what should I do from here to get the next k right? So then here I would want this to be 4. Which would mean don't go back by k, go back by 2 times k for the next batch. Let me okay, go back by 2k. These are go back by k. So it's like offset, or I'll just call it I, starts at k. Or I is like how much you go back starting from k. No, I has to be an index. So I starts at 0. M is like a multiple. It starts at 1. And what you do is nums of k is equal to nums of k minus multiple times k plus I. And then you do this for the first k. For I in range k. All of this needs to be mod len of s, len of nums. So does this. But then how does the multiple work? So you do the first k like that. This needs to be plus I. This is too complicated. Let me try doing this example a different way. What goes into this position? The thing that's minus k away goes there. So here you go. Go back by k. So here, minus k would be 1, 2, 3. So you put a 5 here. Then here you put a 6, and then a 7. Wait. Put a 5 here, and I'm gonna swap. So you put a 5 here, and you swapped the 1 over there. Then you put a 6 here, and you swapped it with a 2 here. Then you put a 7 here, and you swapped it with a 3 here. Okay. Now these are right. And the rest is wrong. So for the first, okay. Then how do you get the right value here? So the right value here, you can't go back by k because you know that it's already been swapped, but now you want to know what it got swapped with, and the thing it got swapped with is the thing back by k. So go back by 2 times k for the next k. So that's going to let you say this is 1, this is 4. But now, are we in trouble again? I guess for the next one, we would say, go back by 2 times k. So you would say 2, 4, and then go back by 2 times k, so you would say 3, 4. And then we're done, but we don't know we're done. So what if we tried going back by 3 times k for the next one? That would be bad. So we would go back 1, 2, 3, 4, 5, 6, 7, 8, 9. We would swap this 2 and this 4. Like, you don't want to do that. I guess... Do you already know that you're done if you have less than k left to swap? We could try this again. K equals 4. So that would make you say 1, 2, 3. Okay, so this one I go back by 4. So 1, 2, 3, 4. So 4 and 1 are swapped. This one I go back by 4. 1, 2, 3, 4. So 2 and 5 are swapped. Go back by 4. 1, 2, 3, 4. 6 and 3 are swapped. Go back by 4. 1, 2, 3, 4. 1 and 7 are swapped. Wait, how did I end up with such a messed up thing? I think I did it wrong. Go back by 4. 1, 2, 3, 4. 4 and 1. Go back by 4. 1, 2, 3, 4. So 5 and 2. Go back by 4. 1, 2, 3, 4. 6 and 3. Go back by 4. 1, 2, 3, 4. So 1 and 7. Okay, I guess that is how messed up it is. And now we're not done. Even though we were done when we when we couldn't do another k more. I know it's gonna be something like this where you swap stuff into the right position, and then you remember where to find the right values. Because when you want to go to the place where the value would have been, you know that it's not going to be there anymore, and you know where to look instead. But I'm having trouble thinking about it properly. I guess it seems like it works for the first 2 cycles, this idea where you go back a certain amount, or like it works until you well, I don't know, does it continue working here? So if I say go back by 4 times 2, then for here I would say 1, 2, 3, 4, 5, 6, 7, 8. So that would be bad to swap this and this. How can I swap them in a way where I know where to look for the next thing? So maybe I have to do like a three-way swap or something where I'm not, I don't know. I mean, I guess they didn't say in the follow-up that the O1 extra space solution should also have linear time. So we did come up with an O1 extra space one, and I wonder if we're just trying to do something not possible. It seems possible though. It doesn't seem impossible to just keep track of where the swapped out values are. Maybe we should just try this again in a different way. So you've got this, and you want to push everything forwards by k. So I think the thing is, for the first half of the array, maybe it's not about k. No, it is about k, because once you get up to k, I need a bigger array. Let's just do 8. So I can directly, I know where this goes. This goes into I plus k. So if I just put it there, 1, 2, 3, I lose 4, 5, and 6. So let's say I swap out 4, 5, and 6. Once I do that, for k things, I can't do it the same way anymore, because now I'd be trying to push 1 up to here. So here I know where to find the value that used to be here, and that's to just go back by k. So for the first k, you go back. For the first k, you push it 4 forwards. For the next k, you grab the value back by k and you push it forwards. But the confusing thing about what I'm doing there is both sides, both indexes need to change. I'd rather do it where like you have just I on one side. So that's what I was trying to do here, where I just say the value of k plus I is you go backwards by m times k plus I. That's what this is, except it doesn't work once you get to the end. But it'll work for a while, right? Like what if I had 8, 9, 10, 11, 12, 13, 14. So for the first K, you end up with 1, 2, 3, 4, 5, 6. Then for the next K, I go back by 2 times K. So 1, 2, 3, 4, 5, 6. So 4, 5, 6, 7, 8, 9. Then I go back by 3 times K. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, okay, this is basically this, but I'm using the first K elements of the array as my buffer. That's the right way to think about it. As my queue. Okay, that is the right way to think about it. So let's comment this out. I don't actually have a queue. I'm gonna use the first K elements of my list as the queue. So queue is gonna be an index into my queue. I don't need that because I is already, okay. For I, so we still need to do the appending and the popping left. We just need to think more carefully about about how to do that. We're going to be overwriting the things. So basically, I mod K is my index into Q. So at that position, first we're going to pop it out. Temp equals nums at Q. So you're going to be equal to temp. And then we're going to replace nums at Q with this. I guess this has trouble once you wrap back around, I guess. Let me add a test case that goes 7, 8, 9, 10, 11, 12, 13, 14. Okay. It just has trouble when you wrap back around and you're trying to fix the queue itself. Why does it have trouble though? It's not just failing to do the last swap, is it? It's not just that I have to do that. I don't know why it would be. No. Or that I'm doing one too many swaps? No, it can't be that. I want to actually add test cases. I keep why is it any different when you come back around? So I'm using the first K as my Q. And then by the end, I have the right elements in it, but I'm not putting them in the right place. Couldn't, no. I was gonna say, could it be because of the order that I'm swapping, but it shouldn't, because I'm using a temporary. Variable. I mean, I'm taking advantage of the fact that my queue basically already has the right values before we start, and then we're starting on the first non-queue element. It has the right elements for the queue, not for the resulting list. But by the end, it should have, I mean, we see that it does have the right things that you would want to put in those positions. I don't know why it would be any different when you come back to it. Why? Because the position you want to place stuff in should be incrementing by 1 from the beginning, and the position that you want to take from should be... Oh, no. Well, okay, I'm thinking maybe the issue is... I don't want to... I don't want to write back into the queue past a certain point, because that I'm overwriting stuff and I'm not gonna need it. So if I minus k, I'm trying to say like only at the end do you not do this. If len of nums minus I okay, here. If I is less than len of nums minus k, then you can do this. Otherwise, you gotta stop near the end. If I yeah, this is what I want. But it broke stuff. Am I off by 1? Does this make sense? It's like, I don't need to be writing to the queue anymore past a certain point because I'm never going to read from it. In the last iteration, I only want to be placing stuff in the right place. But I could be destroying the queue by placing stuff in the right place. This is so hard. It's just it's just at the very end, once I'm placing the stuff back from the queue. I mean, it is true that I don't need to be writing to the queue past a certain point. But that breaks everything. I guess it doesn't break everything. This is so confusing. How do I get those last few? Well, I wonder if I could place things into the queue in a way where I know they'll be in the right position at the end. I don't think so, though. Like, what if I just didn't do anything past a certain point? I thought that was a promising idea. But maybe there's still a way to do it. It's like I don't know, it's like right now I'm using the queue. The way the queue works is the elements in it don't actually move. I'm just incrementing my pointer like this. Then at the end, it's supposed to get smaller, which is just the same as like if it were an actual queue, I would start popping stuff off and not putting stuff back in. No, because I could just put stuff back in and then never read it, so that would be fine. It doesn't have to get smaller. Like, it didn't get smaller in this one. I don't think there's a different order that I could put stuff in so that the queue at the end would be done. I mean, this obviously doesn't make sense because I could just say -k up here. But that's not working. It's so hard to think about. Like, I know that the queue is getting messed up because I'm writing to it while I'm still using it. I'm writing to it outside the context of it being a queue while I'm still using it. I don't have an intuition for like, in what way am I messing it up exactly? And how could I not do that? And I'm just staring at it, like trying to see if I can figure it out, but like, how about if I do minus k here, then the queue, this is the state of the queue before I go through the last iteration. So Q should be 0 at this point. Actually, yeah, why don't you just print nums at each step and we can just take a look. So our queue starts as 1, 2, 3, and we use that to place 1, 2, 3 over here. Then our queue is 4, 5, 6, and we use that to place 4, 5, 6. Then our queue is 7, 8, 9, and we use that to place 7, 8, 9. Then our queue is 10, 11, 12. We use that to place 10. Eleven, 12. But the 13 went into an unpredictable position while we did that. The weird thing is that it was right before we finished. And then in this one, here our buffer is 10, 11, 12, and we use that to place 10, 11, and then 12 goes back into our buffer, which is right. And then we try to do the last two, but we mess up the 12 while we're doing it. So in order to not mess up the buffer, if I use it from right to left instead of left to right, then while I'm writing left to right, I am not overwriting stuff that I haven't, or I would be overwriting stuff that I haven't used yet. Which is the opposite problem. So here, up until this point, everything we've done is right. But now I wish that my buffer didn't start back here, because now my buffer starts somewhere where I've already fixed the answer. Is there a way to say buffer has to start later than me? Later than I plus k? Mod len of nums. So it'd be like if Q is less than this, but it's always less than that. It's if I is at the, what am I trying to say? If this is less than k, and Q is earlier, then I want Q to start after me. I don't know. It doesn't really make sense. Because here I don't even know. I don't like this. I just fixed all the off by one errors until there weren't any, but there's no way, right? Let's try submitting. Okay. If k equals 0, return. Yeah, you do always have to have the mod to come after. So this +1 mod of len of nums. Would that let me get rid of this also? No. If k equals 0, return. Yeah, and this is just a regular example. Well, maybe I should just do k equals k mod len of nums. And then do that before checking if it's 0. Okay, now here's just a regular error that my random... Can I just remove a test case? Here. My random off by 1 fixes are not real. They just hid the problem for the test cases I was using. I wonder if it's a parity thing, like when it's even, I should have an extra 1, and when it's odd, I shouldn't. I don't know, I'm just kind of trying stuff now. So this would be k mod 2. Or the other way around. K +1 mod 2. Okay, it's not about the parity of k. Is it about the parity of the length of the numbers? Nope. I am off by 1 though, and it's fixed by either doing an extra iteration or not doing an extra iteration. So I think it is some parity thing. I'm just not sure what. So it might be a combination of the length of the list and the and k. I don't know how to tell whether to do the 1 extra 1 or not. I've tried every parody thing I can think of. It's not just the length of the numbers. It's not just K. It's nearly just K, but actually this is weird because I'm off by a lot here. Am I even right if I do 1 less here? No. I'd have to do 2 less here, right? Yeah, wow. Well, it can't be like len of nums. It can't be like minus K. Okay, and this thing is still crazy. I forgot that that thing was still there. Oh, this is so frustrating. I'm really close. I just can't get the last few numbers right, and I can't think clearly about what I have to do to get the last few numbers right. Because this thing kind of made sense to me. It's like, once I wrap back around, can I just call this index? This one is the index into my queue. This is index into my list. And this is index. It's getting easier to read, but no, that's not gonna make it easy. This thing is still weird, but it makes sense in this example. I don't know what's going on in this example. So after the first iteration, here we've moved this is our buffer, 1, 2, 3, 4. Then we place 1, 2, 3, 4. I at this point is 4. I mod k is going to be 2. So now our index into our buffer is right here, which is right. And our index into the list is the same. Hold on. So we start with this as our buffer, as our queue. Then we place 1, 2, 3, 4. Oh, and then we should be done, but we do one more. And we swap 5 with the starting index here. Let me not do the -1 here because it's just hard to think about. So this is our queue. We place 1, 2, 3, 4. One, two, three, 4. Now our index into the buffer is going to be back here from before where we are. From like our index into the buffer is earlier than our index into the list, which is bad. When the list when the index into the list rolls over and the index into the buffer is before it, that's bad because now we're going to start messing up stuff that we've already set correctly. 1, 2, 3, 4. But I guess the other thing is, what if we just returned here? That works here. It doesn't always work. So 1, 2, 3, we place it here. 1, 2, 3. Then our buffer is 4, 5, 6. We place it here. 4, 5, 6. Then our buffer is 10, 8, or 7, 8, 9. We place it here. 7, 8, 9. Now our buffer is 10, 11, 12. We place it here. 10, 11, 12. Now we're right, but we're about to mess it up. Should I say if Q equals 0 and we've rolled back? So how can I tell if we've rolled back? It would be if index is less than k. So once we circle back, don't keep swapping stuff. That worked for almost everything, except this example. So 1, 2, 3. Goes here. 1, 2, 3. One, 2, 3 goes here. 1, 2, 3. Now we've got 4, 5, 6, and that's going to go here. 4, 5, 6. Now we've got 7, 8, 9 in our queue. We place that here. 7, 8, 9. Now our queue is 10, 11, 12. So we're going to place 10, 11, 12. Now I'm saying just return because we've looped back around. We're going to start messing up our queue if we keep going. Which is true. But we weren't done. But it's not like we wanted one more, because then we would have replaced the 12. This is the instance where we need a new queue. But I don't know how to think about that. I don't know. I just can't get the last few. So if I don't have this, then I get the wrong answer on everything, but I go through the right answer. Like, I always had the right answer at one point. And in this case, it looks like I had the right answer right before the last one every time. But I know that's not the case on all of them. Because on some of them, I had the right answer even earlier. But how can I tell when I already have the right answer? It's very nearly when you loop back around. It's do one less than everything. Maybe it is a parity thing now. So you don't have to do one less than everything. Or yeah, I can, if I'm returning here, that takes care of the one less for most of them. Which makes sense, because doing one less didn't necessarily make sense. But here, 1, 2, 3, 4, 5, 6 goes to 4, 5, 6. 7, 8, 9 goes to 7, 8, 9. Now I have 10, 11, 12. So 10, 11, and then I place 12 in the first place. But I wasn't done. Like, that's where doing continuing but with a queue that's bigger, or that starts later, almost makes sense. But then for almost all of these, I'm swapping 1 times too many now. Even for the one that I did this for, I'm just swapping 1 times too many. Like, this solves most of them, but it makes no sense. And then sometimes you needed the extra swap, right? 3 and 8. No, 3 and 8 were still wrong. 3 and 8, you needed 2 fewer swaps, right? That's just 8. I don't know if I'm going to be able to figure this out. This almost works, but once you loop back around to the queue, you start messing up your queue, and I have some heuristics that help, but I don't have anything that actually gets the queue back in the right order. Can I say less than index? It's the same thing. Because if index were before Q, that would be okay. The problem is when Q is before index and index is less than K, because that means we've looped back around and now we're about to start messing. With the answer. Or what am I trying to say? Then the queue, yeah, then by storing stuff in the queue, we would be messing with the answers. Okay, that's as close as I can get it. So I think I'm just going to submit my O of n answer that has an actual Q and that's never wrong. And just take a peek at how other people did this. Wait, what is this? First of all, this is technically not O of 1, but you could do it. O of 1 space, because reversed makes a copy. So reverse the whole list, then everything up to K you flip, and then everything after K you flip. Huh. So reverse everything, so you go from 7 to 1. And then yeah, that makes sense. That's crazy. I wouldn't have thought of that. But that makes perfect sense. I wonder if anyone did the thing that I was trying to do. What is this? No, this is not using O1. With and without reversal. Yeah, give me a without reversal. No, this is the splitting at K again. No, this is splitting at K and reversing. What was the first one? They're the same. Oh, but one used a temporary array. Well, this is not. Yeah, I guess this works. I would say this is not in the spirit of the question because you're changing the length of the list, and if the list is not a linked list, then this is not fast enough. And it didn't say that it would be a linked list. Yeah. Okay, so nobody did the thing of using the list as a queue. Actually, what if I search for queue? But this is creating a... This is using a new queue. I want a queue. Okay, I mean, maybe the thing I was doing just doesn't work, even though it is really close. Using list as queue. No, that's the one that's not real. This is using a literal queue, so that's not going to work. All right. That's too bad. I mean, the thing that we learned was cool. The thing where you can just split at the right place and reverse both sides. I didn't actually see any implementation that does that in O1 space because they all involved having copies of the list as slices, but you could do it with O1 space. So that's interesting. It's too bad that the thing I was doing wouldn't work. It was really close, I thought. But anyway, on to the next one. Number 190, reverse bits, difficulty easy. Reverse bits of a given 32-bit signed integer. So if you have this, you return that. Okay, so we are just going to have to use some bit shifting stuff. And I'm guessing it's going to say follow up, do it in place. No. Follow up, if the function is called many times, how would you optimize it? I'm not sure what that means, but let's... so this is easy with a queue. From collections import deq q equals deq for while n bit shift it to the right. That's going to be the last thing you do, and bit shift equals to bit shifted to the right by 1. Take the first bit of n, so n, or actually I don't even want a queue, I want a stack. Stack equals this. Let me just call it bits. N and 1. This tells me whether the rightmost bit is a 1. So bits dot append this. That's going to give me all of the bits. Now I want to make a new number. ret equals 0 for bit in while bits. I want to do them in the other order. Bits.pop, bit equals this, ret, we're going to add bit to it, and then we're going to bit shift ret to the left by 1. We return ret. I guess I did do equals plus. Is it with plus equal? Does it work? No, interestingly. So why don't we print some stuff? Let's start by printing binary representation of n, and then print what I think the bits are. So am I getting the right bits? I should be putting them in the reverse order. So 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 1. Okay, so I'm getting the bits in reverse order. Then I'm popping bits from the end, and those are going to become the most significant. Oh, I'm just rebuilding the number back. How it was. So I guess I do want a queue. Collections import geek. And then I want to pop left. Gave the right answer here, and it gave the wrong answer here. How can it give the wrong answer? Maybe because I'm bit shifting an extra time or not an extra time when there's a 0, when there's a leading 0 or something. Print binary of ret. So in this case, wait, I just got the same. Oh, wait. When it says reverse the bits, does that mean it's expecting me to put the first, like, does 1 become a huge number, or does 1 stay 1? Like, does it expect me to put it at 32? N must be even. Why must n be even? Okay, so I was doing it wrong. Like, it matters that it's 32 bits. It's not just that you reverse whatever bits you have at the beginning. So so let me just start over. ret equals 0 for I in range 32, ret plus equals n shifted to the right by 32 and I return ret. No, not by 32, by I. Oh, and then don't plus equals it. Well, yes, but shift this whole thing back left by 32 minus I. Print binary of ret and print binary of n. And I wish they were z-filled to 32. So how about skip the first two and then z-fill me to 32. Okay. I wonder if it's just a matter of it's, oh, okay, yeah. That's why I wanted it to be even, maybe. No, I guess I'm not sure why I wanted it to be even. But anyway, submit that. So I'm in the cluster. How could you do better? I mean, you can't necessarily do better because the CPU does stuff 32 bits at a time. But I could do something more like what I was doing before, where I iterate where instead of bit shifting n by I each time, I could bit shift by one more than last time each time. So I could be modifying n and shifting it by one each time. But I don't think that would be faster. Just because of the way CPUs work. Like, I think doing this is as fast as shifting it by one. And it looks like this is all variance. Yeah. All right. Well, that'll be it for today. Hope this was helpful. Please leave me a like on Leetcode or on YouTube if this was helpful.